Kevin. Okay, cool. Great. Also confirms that you guys are not sleeping. So the previous speakers did a great job, I believe then. No, yeah. So interestingly enough, Adonai was focused on a lot of engineering and Adhiraj covered a lot of research stuff, and mine is gonna be a good mix of both. It's gonna be a lot of machine learning engineering in there, applied machine learning research in there, and some pure research as well baked in. So yeah, stay tuned. My aim is let me first share my screen, then let's continue. Oh man, so many things are open. Yeah, I'm gonna go to and fro. I'm not gonna just stay in my slide, so be prepared for that mentally. But for now, let's start with the slide. So the reason why I kept the name of this session as the last mile of OCR is because document AI is very interesting. It's not as how do I say cool or sexy as compared to your mainstream frontier LLM space where daily you see a new Codex model, a new Claude Code Opus model getting released. And then there's a new war going on between I don't know that OpenClaw and Hermes, and I don't know if there might be some more companies that have released their own harnesses. But yeah, interestingly enough, this is a very exciting times to be alive. And and in this time also document AI, document processing is not so bad, and it's still so popular that in the last 2 years, if you see Google Analytics, you'll see the graph. See, the last decade it was like this, but then in the last 1 or 2 years, it's like shooting up like crazy, which means people have shown crazy interest in document AI, document processing in general in the last 2 years, and a lot of companies have is evolved, right? So there's a reason behind it because now with the new agentic AI, with the new capabilities that we see in the LLM world, they're getting reflected in document AI as well. And there's a renewed interest because I don't know if you believe whether you will believe me or not, but if you put in your documents in LLMs, they might not succeed in more than 50% of the cases, depending upon the complexity of the documents you're putting in. But I'm still generally saying that, you know, assuming that you will put a variety of documents in there with some complicated layouts. But yeah, seriously, the focus of these LLMs is not extracting text or meaning from your PDFs. Although the level of intelligence, the level of spatial reasoning, the level of localization capabilities that are uh, getting enhanced within these LLMs is directly affecting their understanding of documents as well. But still, the focus is has never been document understanding, so they were never designed for that. And that's why you will see them struggling with a lot of geometric understanding within a complex layout documents. Okay, so here we are going to discuss a lot about the last mile, which means the agenda of our workshop is going to start from where these OCRs and LLM starts failing, right? So if you think about simple documents like the research paper Adhiraj was sharing is an example of, like if you see that archive, actually that is an example of a simple document because you have like a two-column layout, you have text, you have clear lines of distinction. The tables might not be that complex either. It's not like multiple large spanning tables across pages with complex cell paddings in there, multiple headers merged together or something. So that's a good example of something that you can use LLM for. Mm, Yeah, like it, I think it will succeed like in more than 80% of those documents in your archive. Oh, one thing I wanted to highlight here, autonomous auditable document processing. So you should know that in the world of document understanding, document processing, in short, we can call it IDP, intelligent document processing. That's a very common jargon in the world of document AI that we use, right? So if I keep calling it IDP, just understand that's what I mean. So autonomous auditable document processing. So everyone in IDP is chasing autonomy, which means like the manual labor that goes on into handling document processing is extreme, and humans would never want to be a part of that. They want to do cool, interesting things. So they want autonomy, which means they want AI to be able to handle most of this without babysitting, right? So that's what I mean autonomous. And auditability is, as you can imagine, like if you cannot backtrack where the results are coming from, then you might not even have trust on it, right? So you need to be able to backtrack. So your ground truth, where is the extraction coming from, right? That needs to be audited. So that's what it means, right? So auditable, autonomous document processing, right? So that's what you need in uh, yeah, in real world document AI. So that's what at Landing AI we are striving for. By the end of this workshop, the ambitious goal that I have in mind is to make you convinced that to make you feel that I'm cool enough and we are cool enough as a company that whenever you see somebody and some crazy complex document, you tell them that, hey, go to Ankit, go to Landing AI, try Agentic Document Extraction ADE from Landing AI, because that seems to be cool, right? So let's see if I'm able to do that. Yeah, so there are some links here to the playground where you can go to the playground, put your documents in, and quickly do your experiments. It's only for experimentation and demo and light testing purposes, not for production. But yeah, really solid playground for you to be able to quickly start understanding the capabilities of the product. Some notebooks that I've prepared for my previous workshops, but I just kept in here if somebody's interested to see end to end how the pipeline works using our APIs. Previous workshop link I did with Data Science Dojo that has a lot of content in there which you might like. This is from Andrea, our applied AI engineer, who has talked about agents and how you can drive document AI with agents. So yeah, some interesting things for later. Quick introduction for me. I have been extremely passionate about developer relations, and I have been building this function in different startups, primarily startups, Abacus, 12 Labs, Rockset, which got acquired by OpenAI, and then now LandingAI. So these were some of the companies that I have had exciting times with. Before that, I was a computer vision and NLP researcher, invested 2 years in pure research at the intersection of computer vision and natural language processing, to be precise. I was working on encoder decoder neural network based image captioning architectures, and then before that, I was a full stack developer. And then, side note, yeah, I'm a crypto trader as well. I'm self-teaching myself since the last year, and I think I'm getting better and better, and I love day trading. Instruments are crypto, so if anybody's interested in that, feel free to reach out after this talk. Um, yeah, philosophy is something that I'm very interested in. I read a lot of books, and I don't restrict myself in any particular area. So pretty open if you have any recommendations. Adventure sports, extreme sports is something that I just love. So if you are in Bay Area, want to hang out for some adventure sport, most welcome. Okay, by the way, one more thing, before I get into the crux of this. If you have any question, feel free to raise your hand and I'll stop. Right? And remember, that question should be around something that you don't understand that I just explained, right? But if any other side question arises, you feel free to write it in the Q&A or chat, right? But if something is not clear that I just covered, then feel free to raise hand and I'll stop and address that. Okay, let's go. Agentic extract APIs. So this is something that I'm very excited about. Extraction. So what does extraction mean? So let's say you have a document. You parse the whole document, which means you just give it to a parser and it extracts everything that it finds in the document, which means like your text, your figures, your logos, your attestations, right? Don't think just like in terms of text. Think of like the whole meaning of the document. There might be a figure, there might be a caption, there might be some text that relates to that figure, right? So it's about the meaning, associations, right? Parsing the layout, the way a human do. It's not just about like extracting text, right? So think holistically when you think about extracting from a document, right? So extract in IDP has a very particular meaning. Your first step is always parsing, and parsing automatically means that you want to extract everything, the whole juice out of your document, everything, right? You might produce an MD for downstream LLMs or JSON or HTML format, depends on the product and how they are architecting it. But the idea is extract everything. That's parsing. Then the next step is extraction. Like it's called field extraction to be more precise, which means you might have like specific fields, not the whole thing you want to extract. So that's where field extraction comes into play. Okay. So our latest launch was Agentic Extract APIs, which means if you have like, I don't know, millions of documents and you have some common fields across, like let's say name, invoice number, whatever, there are many, many documents that have all those common fields and you want to extract them, then Agentic Extract lets you do that, right? So it is very generic, very generalized, which means that, and very scalable, which means that you can literally have millions of documents. You can have very, very large tables spanning across pages within those documents. You can have like really large arrays. Yeah, and generally what happens is you have like some sort of schema for these fields, and then you use that schema to extract those specific fields, right? So it's like in this uh in this version of agentic extract, you can have sorry, yeah, I will just shut my mobile off, otherwise it will distract me in my Slack. Okay, so what you can have is the schema can be infinite, which means like it can be very, very large because if you have millions of documents, imagine your schema could be very large too. So we call it infinite schema handling, right? For those who doesn't understand schema, don't worry, I'll come to it. But for now, just understand that if you can have huge number of fields extracted, you can have a large schema corresponding to those fields. You can have very, very like high number of documents, and then you can still be able to extract from them using this. So I'm super excited about this. That's why I kept it as the first slide because this is really a hard problem. Enterprise data is unstructured. I briefly alluded to this fact that document AI is a huge problem. It might, yeah, I don't know if you consider that cool or not. If you dig deep into this world, then eventually I'm pretty sure you will find it, you will be convinced that it's actually a cruel problem to solve. But yeah, initially it might not look as cool if you compare, especially with the frontier LLM space. But yeah, uh, it's a real problem, man. Like 90% of enterprise data is indeed unstructured PDF, be it the origination of these PDFs, be it digital or in paper, handwriting and stuff. Yeah, they're unstructured and uh verticals like fintech, health tech, they're constantly hustling to make sense of all these unstructured documents. Enterprise data is locked inside documents. Yeah, I think there's a lot of stuff here, but I'll eventually cover it, so I will not go now into this. But the idea of keeping these slides was to for you to later refer these things if you get interested. Yeah, so this is some of those complexities that I was mentioning earlier, right? Like you can have complex tables, you can have really merged cells, different paddings, different alignments, right? Different column spans, right? Yeah, as you can see, different merge tables are merged in very non-neat manner, right? So real world documents are really complex, and there's no like fixed layout to them that you can bank upon and train your model for, right? Like their diversity is crazy. It's yeah. So that's why like you have to have a very generalized system that can take on all these layouts. And that's where in ADE, Agentic Document Extraction, we have layout agnostic parser, which means like irrespective of what layout you throw on it, it will parse, right? Without any fine tuning, without any training. Okay. So there's something very interesting in this slide that I wanted to cover quickly. Uh, Vision first AI agentic architecture, right? So, and the accuracy. So, what we did was I actually personally liked the Doc VQ&A benchmark because of the way it evaluates documents. So I went ahead and created a pipeline and evaluated on the evaluation split our DPT2 model, document pre-trained transformer 2, which is the latest. And then it got to like 99.16, which was not astonishing because I kind of understood the accuracy of our parser, but yeah, it sounds astonishing when you look at how it beats the human accuracy on that data set, right? Results are transparent. You can go and check my blog out and you'll see. But the reason behind this accuracy is our paradigm, is our philosophy of vision AI first, agentic architecture, and data-centric approaches. How? I'm gonna explain in a bit. But just understand that since like this is a visual AI, computer vision kind of a workshop and space, and you guys are interested in that space, understand this that our focus has always been vision first and visual AI, even when it comes to creating a parser or extractor for documents, right? Because if you think about it carefully, what are documents? They're not just text blobs, they're visual artifacts, right? Like they're visual representations of information, right? Like you need, as a human, you parse that information quite naturally and innately, but for a machine, it's actually not easy. Okay, so why is it not easy about for these LLMs? Because if you think about how LLMs work, from 2000, sorry, from 2017 and 18, the oh man, my protein. The 2017 since 2018, like transformers, the architecture underlying these LLMs have not changed. It's the same transformers, and the phenomena is the same, right? It's autoregressive. It's next token prediction after all, right? And all these new emerging agentic capabilities, what are they? They are just a scaffolding on top of these transformers. So if you think about their training, yes, models like Gemini are multimodal, and they were trained on a complex mix of images and stuff, right? Along with paired with text. But still, like, if you think about it, these modalities, for language modality, it has very strong priors. It has structure, very strong syntactic structure. Semantics can be easily from those priors, right? That language has. So because of the strong priors and like internet scale data on which the LLMs are trained for like on the internet scale text, right? Text data. Because of these strong priors on those text data, these LLMs kind of succeed in the next token prediction quite well for even the most complex predictions, including your coding tasks. But when it comes to language, spatial reasoning, that's not that easy. That's not straightforward because of the weak priors, right? And this complex mix in the training, I don't think that it really leans as heavily towards the image as it leans towards the text, right? So the idea is vision doesn't have strong priors. Like imagine like if let's say I give you four frames and I ask you what's in the fifth frame, it will be extremely hard as compared to a sentence, right? That's so like obvious, right? So that's what I'm kind of trying to say here. So spatial localization, like things like making bounding boxes, counting is a little different, but yeah, still like the compositional geometry and visual cues, these are hard for LLMs to understand because of which they're bad at counting as well. And these things come very easy to humans. So sometimes we get surprised that, oh, LLMs are struggling here because we don't, right? But think about like if you really think about like how what is the basis of an LLM training, then you will understand like why they struggle so much with vision. Okay. So it's kind of I explained already. The same idea about text versus vision, right? Vision is continuous space with weak priors, pixels don't come with obvious tokens, right? Semantics must be inferred from structure, and that structure is weak as compared to text. And that is why things like visual grounding, spatial reasoning are very hard. Okay. I'm just checking, taking a quick look if there was a raised hand. Jimmy, let me know if there's a raised hand so that I don't have to look.
We're good to go.
Okay. Okay, yeah. Spatial reasoning is hard. I already explained. I think you already understand since there's no raised hand. Um, okay, coming back to the same thing. So I said visual first. Now by now I think you have a little more understanding of why we are visual first, right? Vision first. Because that's where these LLMs struggle, because that's where the weaknesses lie. So you have to have a vision first philosophy in order to address that weakness, right? So and it's not just like it's not like reverse engineering that, oh, LLMs are weak, so let's just engineer something to make it strong, to make the system strong on that, right? It's not about that. It's like fundamentally think about how your how the document AI, what the document AI needs to understanding for better document needs to address for better document understanding, right? It's the fact that documents are visual in nature. They're visual representations of information, right? Your PDFs, if you see them, they're very visual. And for you, that visual structure comes very naturally, but for systems, you need to be able to think about how to make that natural for them, right? And that's why this is what the challenge that we have been addressing, and that's what we have done so far in the last 1 year, like trained vision models that addresses these pain points like spatial localization, visual understanding of the layout of the documents, right? Sequencing, like how different segments of within your PDFs, your documents, how they're ordered, right? All these are like different problems to solve, like where are the chunks located? How do we classify the chunks? Are they figures? Are they text? Are they attestations? Are they logos? Are they something else? Right? Are they tables? And then how do you ground them into boxes? Right? Um, and then what is the order of reading? Right? So as human, you know that machine should also be able to understand that. So you need models. You need for understanding all this, you need very specialized models that are vision first in nature, right? So that's what it is. That's what it means to be vision first. Then data centric. How would you train these models if you don't have the right data curated, right? So spent a lot of like landing AI has been around like a long time. It's not like, yes, we have been focusing on document AI since a year, but previously we were focused as a visual AI company on manufacturing space and solving a lot of vision, a lot of uh, problems in the vision arena, especially in visual inspection. So we have a long history with vision and images, right? Image modality, video modality. So we have had a lot of data uh, centric practices that we have developed over all that duration, and then now we have applied that to our document AI as well, which means like training all these specialized models that I was talking about using all the data, systematically curated data, and following all the engineer data centric discipline in curating that data, right? So think about it like Andrew Ng, who is the chairman of LandingAI, he coined this term data centric AI. I think I'm not sure which year, but yeah, he coined it, keeping in mind that that the enterprises were, and even the research landscape was going more towards being model centric. And for solving a lot of real world practical problems, you need to focus on data as much as you need to focus on a model, right? Even more, I would argue. So that is why he came up with this term, and that is what Landing AI has been extremely careful about, uh, like data-centric AI practices, which means like establishing systematic, disciplined uh, pipelines for curating this data and continuously evolving that data for training the best models, right? So the key takeaway is for training these models, you need systematic data-centric AI practices and then only you can create the best state-of-the-art models, right? And the third one, agentic by design. So agentic orchestration is a very important thing. So I mean, all you Claude Code users, all you Codex users already understand agentic orchestration. I need not go. It's just think about it in the context of documents now. You have these models that are trained using your systematic data curation practices. And then now, what will you do once you have these models? You need to create a framework on how do you orchestrate these models together so that you can get the best quality output, parsed output from these documents, right? So that's what is agentic orchestration, right? So you might have some quality thresholds, you might have some heuristics, you might have some specialized vision models, you might have LLMs. So all these different combinations of LLMs, heuristics, and vision specialized models needs to be orchestrated systematically to get a threshold of accuracy at the end, right? And systematically optimize for that threshold, right? So that's what is happening agentically behind the scenes. So interestingly, people don't want to do that. Like it's not a product for data scientists who are like just playing with it. It's a product for enterprise folks who are automating their document pipeline. So what they want is All this happening inside your product automatically for them to get the maximal accuracy possible, right? And this is where we have abstracted all these complexities within the product for you. So the APIs are itself agentic, which means they will handle all these complexities and abstract them for you. And you will see the systematic, neat, highly accurate, auditable output as a result. Zero shot, I already explained. No training or fine tuning required, um, which means like you will always get the best quality in for with the same model. There will not be like multiple models needed or different models needed for different kinds of documents, right? So that's a good part. Visually grounded, I told you, auditable, right? Like you need to have traceability. So you need to have visual grounding. That's another word for it, which means like visually grounded. Like where is it coming from? Where is it visually grounded? Whatever you extracted, right? Verifiable to make it verifiable. Schema driven and JSON ready for production. So yeah, schema driven, we'll go through examples and then it will become more clear if it's not already. But yeah, uh, we offer SDKs too right now, Python and TypeScript. You can build your downstream apps using those SDKs if you would like. And then you obviously have the REST API if you want to have more control and flexibility. Okay, so accuracy again, audibility again, autonomous. We already discussed it. I think it's clear. The only new information here is when you talk about cells, we don't just give you where the table is, we also give you where the cell is, right? So if you have a value, you can always backtrace it to the specific cell it came from. So it's cell level source grounding that we offer within ADE, right? So that's the new add here. Yeah, the most interesting part. People, sorry, people always keep asking, how do I quantitatively understand the performance? And that's where my answer goes to Doc VQ&A benchmark that I invested time in doing. And the reason is obvious. We wanted to quantize the performance. But this is the tricky part because a lot of times your benchmarking becomes bench marketing. In the last AI Dev Day in SF, this interesting. Oh man, hey, Jimmy, how much time do I left? I'm getting
Uh,
really like,
you're creeping up on a 2-minute warning.
okay. So just 2 minutes left.
Yeah, and then we'll want to take one question.
Okay. So yeah, so let's quickly go over this. So when you are, let me let me just show you something interesting. This is the Doc VQ&A blog. Uh, See what we do is in this, you get the parsed output after the parser parses it, and after that, you never show it the original image. And you ask the LLM any question pertaining to the image, and it's able to tell you the answer with like, as I said, 99.16% accuracy, right? So what that means, that just means that your parsed output is so rich that your LLM is able to downstream any agent downstream can make sense of your document, right? And so that means that your parse that actually shows your parsing strength. So this is why I always am a big fan of like evaluate your parsed output. So create your metrics that live very close to the parsed output. Sorry, which is not the case with a lot of benchmarks. Okay, so be very careful when you read benchmarks. Here's I think here's the last part that I wanted to discuss. So this is something that is exclusive to this workshop that we have not even released, but I wanted to show you. We haven't released this, by the way, as you can see, it's not in production. But there's an interesting thing. Like there are benchmarks, like let's say, and you will notice the benchmark might say 90% I'm giving to this and 45% to that. And then when you actually see the parsed output, you might notice a lot of inconsistencies, a lot of misses, wrong orderings, incorrect parsed outputs, right? Um, So what I'm saying is like that happens because people optimize a lot of their metrics on the output semantics rather than the agent semantics, which means like the representation form that they have chosen for their output, maybe it's an MD or JSON. Like, okay, I want H1 headings, I want double asterisk headings for this or that. If you like formulate your metrics around those conventions, that's not what your agent care about. What your agent care about is holistically, is your MD representative of the original document or not? So that's what I wanted to highlight, that you should always be careful about that. And one last thing, see, the design choices behind constructing these parsers is extremely important. Like how do you construct the parser in a way that your downstream agent is able to make sense of whatever comes out of your parser, right? So those are the design principles that actually make or break you and eventually ultimately leads to that kind of accuracy. So so yeah, if you're interested, I can shoot you after this workshop more details on this blog. Um, oh, one last thing. But yeah, that has all the details. But quickly, let me show you all the links. I will shoot you in the chat the slides, and it will have all these links, right? So my email, events.landingai, which is extremely interesting. It has 50 plus fintech projects that you can see. They're built in like a matter of 3 weeks. It was not just a 1 day hackathon. So people built these projects very, very carefully and taking a lot of time. So these are not just mere prototypes. So feel free to explore them if you're into financial services and document AI. And feel free to participate in our community by joining our Discord or Circle, right? Or coming to our events. You can follow us on Luma, Landing AI events. And yeah, all the links are here. You can try our product, Discord link, and the Luma link I'll also put in before exporting the slides. But yeah, floor is on for the questions. Let me know.
All
If
right, let's go ahead and take one question. Have landing AI's models been evaluated on archaic document extraction, for example, inconsistent scripts and styles, tabular formats, and even spelling within the same document or document set?
what did you say, Jimmy? Arcade.
Archaic. That it looks like the ARCHAIC, archaic. I'm not sure in the
Oh
context
yeah.
that means.
If it's a specific benchmark, then no. The answer is no. We have only evaluated on DocVQ and a val split, the one that I showed you. Besides that, as I shared with you, like benchmarks, be very careful about that. The best way to understand quantitatively is to curate your most complex documents and then throw it in the parser and then sort of eyeball all the interesting complex things where other parsers or OCR solutions or IDP solutions might fail, and then come up with a conclusion on if the current parser is failing on them or not. And that's the only way to actually do practically this thing. Otherwise, the metrics will abstract the details and give you a false impression. So I'll be very careful with them.